So Tom Rose, Vice President, Technical Marketing. And, it's interesting. Following Andreas's presentation is always a challenge, but I think he set up a really good, the dichotomy that we face in marketing here at Nasuni. There's two things we struggle with. We have to get across to the market. Number one is the noise in the market about everybody's got a cloud solution. Everybody has a cloud angle or a cloud story. Why are you different? How is Nasuni different? And taking what Andreas just talked about for the last 45 minutes and distilling that down to a couple slides and an elevator pitch is not easy. That's been a challenge for us. I think the second thing is what Frederick hit at. It's the cost. People, when they think cloud's going to be more expensive, but I'll get more flexibility, I'll get faster response, I get on demand. But in the case of Nasuni, because of the economics, because we're converging primary storage, backup, DR, synchronization, archive, all these things in one solution, and because we're leveraging object storage as the back end and object storage economics, that makes us less. And we haven't done the best job, I think, in the early years in Nasuni at really addressing either of those two things. I think we're getting better at it, and that's really what my focus is going to be in these next few slides in this next session. So I think I would start with, if you look at, and this is something we always get asked, NetApp says they've got cloud solutions, EMC. You've got the first-party services from AWS and Microsoft Azure. Why are you guys different? How is it different? And you really look at, there's different levels of cloud support, I guess you'd say. And there's a spectrum that you have to look at. And I think what it all boils down to when you get to Nasuni on the far right is that we did two things that nobody else has done. Number one is we chose object storage as the back-end repository for the file system. So it's everything Andreas said. It's data, metadata. The entire inode structure is described in these containers, these buckets of object storage, and that's where it stays. And it leverages object storage durability, scale, redundancy, geo-replication. All that's handled for us by the cloud providers, and also it's lower cost than using solutions like Amazon Elastic Block Storage or Microsoft Azure Disk Storage, which are solutions that are used by Accumulo or NetApp or others. And then you see, the other approach is lift and shift. I want to tier my data to object storage. And again, object storage has been looked at. I think Andreas mentioned this up front. It's always been the cheap and deep repository. It's used for untouched stuff, inactive workloads, archive. We're using object storage for primary, file storage, and it's because of the caching front end that we put in front of that we can do that. So, others say, well, we're going to tier data you don't access very often to object storage, but most of your capacity, your performance tier is going to be on your NetApp array or your EMC Isilon array. And then you'll have this capacity tier that has the extra stuff in the cloud. Well, again, we didn't do that. We said, no, all your data, the gold copies of all files, all metadata, that's going to be in object storage. There is no separate tier. And then we're going to cache copies from object storage out to the edge, wherever you need that performance. And the definition of edge is changing. The edge used to be on-prem. Now, as Andreas just said, the edge is more cloud regions can be the edge as well. So I think that's what we're trying to get across, I think, is, again, the use of object storage as the primary repository. And then the other thing that I think Andreas talked a little bit about, but I wanted to emphasize more, is that when you're managing synchronization and locking at this global scale, and you've got petabytes of data being synchronized, like our customer Electronic Arts uses to synchronize their video game builds across all their 30 dev and test centers, and you've got billions of global file locks across all our customers you're trying to process. You can't do that with a Windows server, right? You need a scalable, elastic service. And so our orchestration center, which is we call it the traffic cop or the air traffic control center, it's the control plane for our product. It's built as a cloud service. So it's scalable, it's elastic, it's multi-region, it's fault tolerant, and it can scale to any level. And you look at competitive solutions that are trying to add synchronization or edge caching to their products, and they're doing it with a Windows Server technology that's based on a box or based on a special controller. And we built our air traffic controller, our cloud control plane, as a cloud service. So those two things, object storage as the back end, orchestration through a scalable cloud service, nobody else has done that. And so when we say Nasuni is cloud native, that's what we mean. And the benefits translate to customers in that I don't have limits. I can store any amount of data. There's no directory file size volume limits, no snapshot limits. I can recover data at any point in time, doesn't matter how far back. I can scale to any level I need, any number of locations. I can synchronize the active data wherever I need it. And I get the object storage economics. And so the solution in general is going to be less expensive than these other solutions. That's been really, that's what we're trying to do a better job of getting across to the market now with slides like this that show the spectrum, and then other slides that show kind of where you're coming from today. You've inherited this very difficult environment because like most companies, you start out with a primary data center, and so you do things you've always been taught to do. You buy a bunch of NAS boxes or file servers, you rack them and stack them, and then you go off and you buy a backup software to back it up. You've got tape or disk targets that you put to hold those backups. And then, you got to do it again now in each remote office because, again, most of our customers have many remote offices. And so they're doing this yet again, in each location. Maybe it's a smaller NAS box. Maybe it's a Windows file server at the edge. Maybe it's local backup on local tape drives or disk. Maybe they're dragging the backups across back to the data center. But still, you got to manage all this environment. And then you got to think about DR. So I've got to, what if my primary sites go down? I might have the backups, but where do I restore the backups to if I've lost my primary data center? So I have to have DR sites. I have to have colo locations. My remote offices have to have their own DR, or else they have to use each other for DR. And then, as Andreas said, the real challenge comes in when I have the same files that I want to make available to many locations and users in different places. And so now I've got to add, more MPLS, more WAN. I've got to add WAN acceleration, remote access tools. And so my environment just keeps getting more and more and more complicated. It's constrained because I can only rack and stack so much. I only have so big a staff to manage all this. It's really costly. And if IT doesn't do a good job of this, then end users take matters into their own hands and they go off and they buy box and Dropbox and they do the shadow IT thing. Right. And this is what we typically, when we come in, this is what customers tell us they have today. And it's the 3 C's: complex, constrained, and costly. And so they could look at just saying, well, I'm going to lift and shift to the cloud. I'm just going to take what I did before on-prem and move it into a cloud data center. And our point there is when you take a technology like a NetApp Waffle or ONTAP, and you just now host it in an Azure data center or AWS data center, you're still taking technology that was designed for a hardware, and you're just moving it to a different place. Now, instead of hosting it on-prem, you're hosting it in a cloud region. And that's not really, all that's doing is moving the problem. You still have these hardware limitations. You still have all these different products. I still need a primary instance. I still need a secondary instance for DR. I still have to back it up, which means I still need a backup solution. I still have users who say, well, I don't want to have to go to the cloud in every location. I need edge caching. So I still need a way to cache things locally and synchronize all those changes. So, just going to a lift and shift or moving the problem to the cloud doesn't change the equation. You have to have really a sea change in in a transformational approach. And that's what Andreas just spent 45 minutes talking about. Is our transformational approach is to take this file system we call UniFS and put the file system in object storage. It lives in cloud storage, so it scales without limit. And we talked about durability, redundancy, geo-replication, all that comes built in. And then we, again, using the Akamai analogy, we cache to the edge just copies of the frequently accessed data, which is typically a very small subset. It's 2 to 5%, maybe 10%, depending on the workloads. But it's a very lightweight footprint that you need. So you need a lightweight compute, you need a lightweight capacity back end for it. And that's why these edge appliances, we call them, are often, they're transient, they're stateless, they're easy to spin up, spin down. They can live on-prem or they can live in the cloud regions now. And not only do these edge appliances provide that high performance access to the shares through SMB, NFS that you need, but they're also constantly capturing the deltas of whatever's changing. And they're snapshotting those changes back into object storage. And so that's where this built-in backup comes from. Every change is going to be, synchronized across it's going to be snapshotted from each edge appliance, date and time stamped, and sequenced in the right order. So if a change comes in from London 5 seconds before New York, you've got both of those sequentially ordered. And that's what's kind of orchestrated by that orchestration platform that we call that orchestration center. That's done at scale through this scalable service that we host in our tenant. It's part of the Nasuni Cloud file storage platform. And so by snapshotting all these changes, you get this infinite version history. It's immutable, it's warm, never changes. And I know I can roll back my entire file system or a share or a file to any point in time. And that's why it's been very valuable for ransomware, especially if customers are getting hit with that more and more now since COVID. And they know they can now recover back to any point in time right before the ransomware hit, maybe 2 minutes before. And so they're not losing anything. It's not like they have to go back to a full backup last weekend or an incremental, last Wednesday. They can roll back right the minute before the ransomware hit. So backup is it all happens. You set your snapshot schedule and it just happens. And we're right in the middle right now of our revenue kickoff, our sales kickoff for our team. And we had customers come on and talk about the value they see in Nasuni. And as Ann said, every one of them talked about the value of not having to babysit backups and not having to worry about disk and tape and media servers and backup servers. And they just set their snapshot schedule and it just happens. And they know that not only can they roll back the file system to any point in time, but we also give customers the ability to let their end users roll back through self-service by tying into Windows previous versions, so they can recover back to versions on their own. So backup is built in. Obviously, the primary storage is built in. And as Andreas was talking about, DR is built in because these edge appliances are so lightweight, you can spin them up and rehydrate them within about 15 minutes. So the need to have all this dedicated DR infrastructure on standby, in case I have to fail over, that goes away too. Because now with Nasuni, I can know if I lost my Kansas City edge appliance, I can spin one up in the Azure Midwest region and have it rehydrated with metadata in 15 minutes. And users can be pointing to it and they can, I can have DFS, point them to that appliance and they can browse the file system within 15 minutes as more data is being cached in the back end.
Hey, Tom.
Yeah.
I've got a question kind of regarding the edge style of deployments. Is one, how many? I guess what's your theoretical max on the number of edge locations that you could have, and then also what's your guys' practical? What's the I guess the largest amount of edge devices you got deployed out there in the field?
Yeah, awesome locations. I'll give you my take, and I'll let Andreas jump in after that also. So really, there's no hard limit. We see we have customers that have hundreds of these to support all their offices. But that was why Andreas talked about the consolidation that we see happening now using the cloud in his last presentation. We're seeing more and more customers now apply cloud resources because they can actually build bigger, beefier, edge appliances in the cloud and support more users than they could, using their virtual infrastructure on-prem. So Andreas, I don't know if you want to talk a little bit about, again, the oil and gas.
Tom, I could add, if you don't mind, I could add just a little bit. I mean, it's really kind of governed by the what can be managed by the management console. And, we have, as Tom said, we have customers that have hundreds of locations that are under one management console, but they could have 2 or 3 that are managing the entire infrastructure or all their locations. So it's really no hard limit. It's just how you set up the system and really set up the management console that governs, what's going to be managed there.
Yeah, the management console, Jason, it can go up to about 500 appliances on the endpoints, and we have customers that push close to those limits, and then we keep upgrading the limit.
Yeah.
If you had asked me 5 years ago, it was 50, and we've been scaling it up. The key thing to the management console is like everything else we do, it leverages a cloud service for all its messaging and all of its internal works. And so, like Ross said, really there is no back-end bottleneck to it. It's more about the implementation of it to make sure it's efficient and the pages are, you have the right display for pages when you have hundreds of items in the list and things like that. It's more of a kind of UI yeah. Design changes. Yeah.
Yeah. Great.
The backbone that's the beauty of the backbone being the cloud. It's,
Great. Thanks.
Well, the other question also is how many users per edge appliance. So again, Andreas and Russ, we've seen now 4,000, 5,000 users on some of the appliances in the cloud.
Yeah, 4,000 or 5,000. That's about right.
And we're getting requests for more. So it's growing. As Andreas said, we're adding capacity and scalability to each appliance as we go.
There's typically three problems people are trying to solve, right? Performance, capacity, and availability. We are constantly working. We know that we are really superb at capacity. No one can match us on capacity. And the other two, we just keep investing on. We made a whole series of improvements this year that improve availability. And we're always focused on how to build a bigger machine that you can put more end users to and change the architecture in that direction.
Yeah, great question. So, so again, we talked about primary file storage, backup. We just talked about why DR is also included in the platform. And then I think, Andreas talked about in the last session how file synchronization is, again, a key part of this. Keeping all these edge appliances in sync through that orchestration service, being able to manage the whole thing through a single pane of glass, which we call the Nasuni Management Console. And again, the message queue there is also managed by the orchestration service as a cloud service. So that's what gives us that scale.
Yeah. I mean, the key to this whole solution, to some extent, appears to be the working set to physical storage or physical data ratio. And there's some workloads that have great working sets and some workloads that don't. And I guess I'm not sure I can claim one that doesn't, but anything that does, I'll call sequential IO, would have a poor working set on a random cache kind of thing. How do you guys handle those sorts of diverse workloads? I mean, with the customers you have are fairly sizable, so you would think they would have workloads all across the gamut of this.
So you're right. The leverage is the key, and we have tuned the algorithms over the years, but really an LRU basic algorithm gives you a ton of lift across all the workloads. Now, you raise a very good one, right? It's like sequential writes, right, coming in. So remember, we're never used for like backups, right? We don't recommend that you use us as a backup target for your databases or anything like that. So that's one whole work set that is eliminated from our universe. But for instance, we have a lot of manufacturing customers that will use us to write manufacturing data, like telemetry data from their machines.
Log data,
And that's typically kind of write once from one direction, and then you analyze it in the other direction. One of the reasons we created the analytics connector, which you're about to see, is to improve the read access speed on that data. But it's very, very rare that data actually gets access from the same point of ingestion. So you're really, you're separating the workload between a kind of exclusively write and exclusively read workloads on two sides. And other than that, right, there are some use cases where we'll increase the size of the appliances above our standard to create a larger working set, but we have not run across our spectrum of customers' use case and stuff like that on any workload that we cannot solve the problem by increasing the size of the appliance and handle that with I think our biggest cache appliance out there may be 100 terabytes for a super exceptional workload where everything absolutely, and it was more like a governance thing where they had to have the copy local all the time.
Right.
Ross Kennedy, you can correct me if I'm wrong, but I don't believe we have anyone else that's been outside the parameters, and it's usually in the single digits to tens of terabytes. And the file systems behind it are in the hundreds of terabytes to petabytes, and it's just like lots of workloads.
Occasionally we do come across the use set or working set, right? It's above like 40 terabytes, but it's not common. It's relatively rare.
The burden is on Nasuni now to explain, well, how is your architecture? How are all these differences that Andreas just talked about, our IP? How is that different, when it comes to actually deploying this in production? How are you different than other solutions? And what does that mean to the customer? And so we've been doing a lot of work now with customers. I think Ann showed that we're a very close partner of Microsoft. They look at Nasuni as part of their file storage portfolio. You've got Azure NetApp files, you've got Azure files, you've got Microsoft Teams, you've got OneDrive for Business, and they see Nasuni with Azure Blob as another the enterprise departmental group and file sharing solution. But a lot of times customers don't get that message. So we have to, tell them, well, if you're looking at Azure files, there's a 100 terabyte volume limit. This customer, actually, this is right from a real customer where they had many locations, they were going to exceed that volume limit. That means they're going to have multiple instances of the file system with all kinds of sync groups, to provide access at the edge. And whereas Nasuni, it's going to be very simple. You have one global file system that can be accessed, by any number of locations, and so just making the differences clear to the customers has been a challenge for us. And I think we're getting a lot better at that through these types of comparisons. And Microsoft's helping us in many cases. And then the other thing we also get asked is, okay, well, NetApp just acquired this company called Talon. So again, it's back to the equation. Nasuni sounds like global file cache, this Talon thing. And we have to come back and say, well, no, not really. We're a replacement. When you look at Nasuni plus cloud object storage, we're replacing primary file storage. We're replacing disaster recovery. We're replacing, obviously, everything's in object storage, so you don't need a tiering solution like Fabric Pool. We also eliminate the need for backup. We also eliminate, and then there's the global file cache and all the Windows servers at the edge that are needed to manage that environment. This is the right equation. It's not just Nasuni versus global file cache. It's Nasuni versus all this stuff. So I think this is what we're, trying to, do a better job of explaining the differences and what that means to customers. And then also, sharing examples of customers who have now evaluated the different solutions and why they've chosen us, like these customers you see here.